Hello, my name is Cooper Hazel, and I'm presenting for Shruti Nemanwar and Michael Bell, and we are elaborating on academic regression analysis in R and why it's a much better option than in Excel. This is a sequel to Cooper's MIS 4460 project that he submitted in the fall, which elaborated on why the linest array function in Excel is also a bad idea for regression analysis. Our problem to solve is replicating Dr. Hodge's summary statistics and two of his three regression models, which are the two-way fixed effects model and the ordinary least squares model. We're also going to elaborate on differences between Excel and R and why R is more widely used. Marijuana consumption and legalization, which is the topic of the paper. The paper is called the Munchies. It's a very hot topic, as over 31 states have decriminalized marijuana in some way, and about 15 states have legalized marijuana for recreational consumption. The model is like my model in the fall, although we use OLS and two-way fixed effects, and the controls are very similar. R is great because of its speed and ease of use, and as we will see when I load in the data, I can execute all of my data analysis in less than 30 seconds, so you can kind of watch the environment populate, which is very satisfying. R can also handle many more variables than Excel, and its regression output is much better suited for academic purposes as p-values are given. Also, we do robustness checks on the coefficients and generate 95% confidence intervals using the coef test function. The biggest thing for me that I enjoyed about R was if I forgot to log transform a variable, or if I forgot to add a treatment effect column, just a simple if-else binary function, but then that column is later in a subset of data, I can add it above the lines and then just re-execute my code instead of, in Excel, I would probably have to do it in each. So I'd have to do it, once here and then once here, and I'd have to write the separate functions and then, double click the column so it populates all the way down. R is just so much quicker in that way, especially if you know what you're doing. And I really enjoyed it. And it was really satisfying, and I've used Excel my entire life, and this is my first year using R, and it is mind-blowing some of the things that I can do. So the data already includes the data that I elaborated on in the 4460 video, which is the food price index, how things were inflation adjusted. Dr. Hodge had already used that data, and he provided it to the rest of the class. So he basically just uploaded a stata file, which is washingtonfood.marijuana. I think it was washingtonfoodmarijuana.dta, which is a stata file extension, into Moodle, and then we downloaded, and we were responsible for the transforms. Here is the linest output, which is really confusing because the coefficients are pasted in reverse order in Excel. So it's not very readable, especially the more coefficients you have. I think I had 16. The table is formatted, as you can see in the screenshot, and I know that because of the way that Professor Iskin explained it to us. Very helpful. And without it, I think linest would be very hard to comprehend and understand. A really big shortcoming is that p-values aren't included in the output. However, you can calculate them using the t.dist function in Excel, and then export that to, you would just do it in the Excel spreadsheet and then fill it over based on cells. But including the p-values in your output is very important and very easy, and it's a standard in academics in terms of variable significance. Here's Professor Hodge's abstract, and the highlighted portion is very important, as those were the statistics we were responsible for recreating, as the introduction of recreational marijuana sales increases per capita food sales by 5 to 6%. And a 1% increase in marijuana sales increases per capita taxable food sales by 0.018%. And because that's a log, it's 0.018%. And as we will see later I guess I'm in the process of creating the table for Dr. Hodge's class. And now we will continue on to the summary statistics. So here's table 1 in Dr. Hodge's PDF file with summary statistics. The highlighted sections for poverty rate and unemployment rate, both mean and standard deviation for treatment less than 0. Those were incorrect, as I verified. When we move to the Excel file, I will show that. And that was just calculated from the R stat description. I'm not going to go line by line through the code in the R output, but it will be calculated I'm just going to run the entire block by itself. And the Excel spreadsheet that I have in the future that we will look at does have the correct updated poverty rate and unemployment rate statistics. And here's the two-way fixed effects and OLS. The third, PESD, that's the panel event study. I was not responsible for that. I just focused on the OLS and the two-way fixed effects model. It is important to note that MJ sales is logged, which is where the 0.018% comes from. There's Hodge's paper. So here I'm just there's some libraries that are of interest that you might want to load in. To select the file, I'm just going to do a simple, I'll do it right here. I'm going to do a simple import data set, just wherever the file is included in the downloads after it's zipped. That's just how I would do it. That's how I've always done it. And here I'm just going to run the entire, as you'll see, the variables increase, and then we start subsetting data and all these other treatment. The treatment pre, that's from treatment less than 0, and treatment post is treatment greater than 0. Treated group is what is used for some of the regressions. I think it's or no, it's not used for the OLS regression. It's treated post that's used for the OLS regression. And here are all of the outputs for the regressions. So overall, a lot of variables. Some are logged in the OLS, some are not logged. Non-tax is non-taxable. Tax is taxable, and then restaurant. Dr. Hodge said we didn't have to be exact, so there is some discrepancies for the restaurant data, of which I'm not sure why, but I'm still within, I think, a couple hundredths, and my variable significance is off a little. But here for OLS tax, I'll do the summary, which is below point. That's where 0.18 comes from, and then we did a COIF test, which is just a robustness check, and there's that one. And then for the tax 2, I think it's the same thing. And this is is that 0.05? Yeah, 0.058. So tax 2, and tax 2 is just because there was a subset of the data I needed to not include one of the counties. So tax 2 and OLS tax are the ones of interest. And then the summary stats that we used the stat.dsc function. And that's where I believe it was treated less than 0, so treated pre, and that's where, is that the treated pre? Yeah, treated pre, we're looking at poverty rate 16.54, and then I think it was 4.8, yep, 823. So here's a side-by-side. I had the exact same numbers. The only highlighted ones are the ones with the asterisks that are incorrect. And then here's my table, and here's the restaurant food where you can see, there's a little bit of a discrepancy. I think that's 2 hundredths and then 4 thousandths in terms of the standard error. And then there's the taxable food. So overall, I thought the project was very insightful. To the right, I have a screenshot that includes the abstract and 1% increase in marijuana sales increases per capita taxable food sales by 0.018%, which is good to know because taxable food is another driver of revenue for states, and it'll be a good way to offset some of the public health costs that might come with increased marijuana consumption. And increased food consumption. Obesity, 40% of the United States is obese. We're one of the most obese countries in the world. This could snowball into something that we don't want to deal with. Personally, I think that marijuana is a safer alternative to alcohol. That's still under some debate. But overall, I think this paper is very applicable especially as marijuana comes into prominence in the public policy sector. So thanks for watching. Hope you learned something. I know I did. And I know Shruti and Michael did as well, because I know, I don't think we did a lot of social science regression in Professor Iskin's class. There's a lot of model building and test, and I think it was, I don't know what the other one was called. It was test and something else, but different type of regression analysis, and very insightful, great learning experience.